Recently I was working with these little data flash boards. So they're based on a 4 megabyte chip, which you can see there in the middle. This is from David Johnson Davies Technology site. And I had a little bit of trouble making them for various reasons, which I go into in the video, which I'll link in here. But in the end, I got 4 working ones, which is fine. And what they do is they just sit on the Arduino Uno in this position here, like so. I'll just refocus. There you go. And then you can store 4 megabytes of data on there. So I use them to for instance, make a fake candle, which worked out pretty well. But along the way, I killed a fair bit of these boards, and I killed them in a lot of different ways. So, for instance, the regulator, little 3.3 volt regulator there, didn't always work, and I ended up getting rid of the diodes. And you can see that there's just traces that go to the GPIOs. And then I was just a little concerned about the actual IC itself. And so what I did was I swapped a couple out, so you can see them here. So these are the dead ones. Well, are they dead? I don't know. So my next idea was to maybe, before I throw these out, because I don't really like throwing stuff out, is to actually test them and see if there's any recovery possible, or are they really dead. So in order to do that, I'm going to need some way of communicating with these ones. So I thought I'd start simple and see if I can communicate with these guys here. Or even, I've got a blank one over here, which is a new version, and it could be used because it's, it hasn't been used in any project, so theoretically it's fine. All right, so in order to do that, there's a couple of different things you can do. You could, for instance, use a USB ISP. So there is that. This is a way of communicating with with anything. I've got it hooked up here to a programming board, but you could, for instance, hook it up to something like this, and then when it's hooked up, now you'd need the adapter, but when it's hooked up, you can then put your IC on here and communicate with it and see if you can pull data off or put data on. So that's one possibility. You could also use something like this, which is a shield which sits over the top of your Uno, for instance. So let's just put that on. So it's a shield that sits over the top, and it's called an AVR ISP shield, and it's used to program AVRs. I'm not sure if it's used to program EEProms though, but it's a possibility. I know that you can use an Arduino to program or to probe an EEProm, so that's a possibility. But what I did have was this guy here. So it is an EEProm programmer. That's what it's billed as anyway, and it's based on this CH341a chip. And again, there's different ways to communicate, but this seems to be a pretty common form of communications, USB to serial. And then it's got obviously the usual stuff on there, like your voltage regulators and so forth. But the idea is that you put your chip into the ZIF socket, and you can program it. And if you look at the writing underneath, so see if I can zoom in on that. There we go. So you've got an idea here of what orientation you use for different types of chips. And for these types of chips, the old WinBonds, you use the 25XX orientation, which is in here. So with the pin number 1 here. So for instance, if we go back to this guy, you can also see a pin number 1 orientation. So if we move that around in that orientation and pop it in, then you could just refocus on that. You could just put a chip on here, and again you can see the pin number 1 orientation indicated, and then theoretically you could read the data. That's not going to work so much for one which is already in situ, like this guy here. So let me just zoom out again. So in order to do that, one possibility is to use one of these guys. So this is a test clip, and you can see that it's got, let me just see if I can see that. Yeah, it's not showing it real well. It just wants to focus in on the background. But anyway, let's try that. Oop. But anyway, that you can see the little pads there, which you can clip onto these guys here, and then the other side plugs into this adapter here. So again, I think it's around about this way. Yep, and you could probably put an adapter on there actually too. So that's one way of probing these ones which are already in situ. If you want to program them up before they're in situ, you could possibly use something like this guy. So he sits in here as well, and then you can put your chip in this compartment here. I actually had to bend the leads a little bit to get it in, but it does fit in there and communicate. So that's the, or does it? It was sitting in there. But yeah, it's not ideal, but there is a way of putting that in. Let me just fiddle around with it, and I'll have a close-up picture, and we'll have a look at that. Yeah, so you can see it clipped in there, and then that's the adapter, which is a SOP8 or SOIC8 to DIP8 adapter, and then that's sitting in the ZIF socket, and that is attached to this CH341a Programmer. So my plan is to firstly try it in this configuration, see if we can't talk to that fresh chip. And then what I'll do is I'll try and use the in situ one with the test clip to try and talk to one of these other guys. And then if that's successful, I want to test these guys here to just see whether or not they are completely fried, or we might not be able to recover them. So that's the plan.
Okay, so we are on Windows to run the program ASProgrammer. It is running under VirtualBox in Linux, so that could be interesting. But what we could do first with the software is select the right chip, which according to what's etched on the top is this one, and then we can read the chip. So this is a brand new blank. So that's finished, and it does look like all Fs. So let's put some random data in there. So 29011963. And what we'll do is we will, erase and write it. That should be okay. Let's try that. Yep, so okay, let's try that again. So 29011963, and we want to program by erasing first. So that erases it. Let's erase. So that's erasing the whole chip, and then program. So that's interesting. Now it does seem to be erasing as part of the process. It might be a software glitch. And now it definitely seems to be writing it. So what I might do is actually quit, start it again, do the old chip detection, and then read. So this will be interesting to see if it's actually contains that data. So yeah, a bit of a software glitch there, but you do need to erase and write this sort of memory in pages, as per David Johnson Davies' blog, and the program that collects the data for the candle as well. So let's see what this looks like, and yeah, look at that, 29011963 random random data. Good one. All right, so now let's go to the candle version. So first thing I want to try and do is see if I can detect that. And here, yep, it's detected the information, which means it can probably read the chip. And what I'm interested in doing actually is not just reading the chip, but maybe saving the data and then writing it to another chip and see if that will reproduce that sort of real candle fluctuations. And the other thing that would be interesting to do too is to see whether or not we are able to maybe change a couple of bytes in it too and write that back. But for now, I'd just be very interested to see if I can actually read it. And yeah, look at that. So that's pretty good. So that is fairly random data. Oh, okay, so that's interesting. So it's obviously didn't fill up that much of the space. Let's just go back up to where the data is again. Okay, so down to this memory location here, which is 1869 and then F. So yeah, be interested to know how many minutes that was of the data. But what I really want to do is save that, and so I'm going to save it to the desktop. Looks like we can save it as a binary file or hex. I'll save it as hex, I think, and we'll just call this candle and save that. Excellent. And now what I might try and do is to write a couple of bytes back to the chip, and then maybe to write the entire file to another chip. Right, so let's start with one of the other modules that didn't collect the data. So this should be blank theoretically. Let's have a look or read. So what I'm going to attempt to do is I have got that candle data saved. And I'm going to load it up into here and see if I can burn it onto the new EEProm and get some candle goodness out of that. And then the last part will be to check those chips that that failed during the process and see if I can safely bin them or subject them to the same reprogramming. So this is now reading as, yep, all Fs. So we'll open the candle. This is the data from the other chip, and now we will program that. Erase and program, yes. So there's the erasing process, which takes a little while. And it should start writing. There we go. So it's writing the 4 megabytes of data. And what I might actually do is I will close that down, run it again, detect the chip again, and now the moment of truth. And the result is, yeah, look at that. So good. All right, let's go and get those. Actually, what I might do is I might plug this into the Arduino and see if not only is this data written onto the chip, but it legitimately produces a candle, which would be pretty cool. All right, let's do that.
Okay, so this is the new module that's just been programmed with the data from the old module. So theoretically, if that transfer has been okay, when I turn the Arduino on, we should get a candle. And there it is. So that's great. Just to show it in its full glory, I'll just turn the light off and zoom in on that guy. Yep, that's pretty nice. So the next thing to do is to have a look at those couple of chips that I didn't throw them away, but I took them out of the project thinking that may have been faulty. And now not only have we got a way of testing them, but also a way of reprogramming them if we need to. So yeah, good result.
So one of the recovered chips, the win bond, is in the harness. So first I want to see if we can recognize it. So if we detect, okay, so that's a good sign. So it's also this one here. And then if we read, so this is the one that, yeah, I guess I would normally throw away, but I've recovered it. And we'll just see if it's still able to be used. Let's have a look. Okay, so that's got random data in it. Now, it should have, it must be one of the early experiments I was doing because there's not that much random data on it. I think I ended up getting something like 100,000 bits of data, so this is nowhere near that. Okay, but still, that's pretty good. And I guess what I really want to do now is just to see if I can also write to it. So if I just go back here and go 29011963 is a random number, and if we go to erased and programmed, yep, so that's erasing. And now programming. That looks good. So now we'll just close that down, start it again, and read it. Oh, after identifying it first, that guy, and read. And the answer is, look at that. That's so good, 29011963. All right, cool. Let's throw the other one in and see if that works. All right, so the second chip is in the test clip cradle. So let's see if we can recognize it to start with. Yep, that's a good sign. And we'll read it. And we've got nothing on there at the moment. Okay, that's fine. Like I said, I may not have actually collected any data, so let's try writing to it with a completely random 4 bytes. And we will erase and then program. And I'll shut this down, start it again. Don't know why I do that, superstition I guess. And let's detect it. And we'll read. Yeah, look at that. Very nice. All right, so that is the circuit working for this week. And yeah, next time we'll look at these data flash boards. We might even expand the memory, but I think they're actually pretty cool little beasts. See you next time.